Okay, so today we're still in the chapter 10. This is our last chapter of the semester, which is kind of exciting and nerve-wracking all at the same time. We're looking at hypothesis testing in chapter 10. Remember, like I mentioned last class, that hypothesis testing is another form of inferential statistics. Chapter 9, confidence intervals, was the other one. So what all that means is that we're going to take a sample and see if we could project what's going on with our population based on that sample. So last class we discussed the population step, and today we're going to move on to the method step. So I'm hoping we can look at the method and sample steps today. So for my method step, again, we're going to have 4 parts under this step, just like we did in the population step last class. And the first one is my null, so H naught. The second piece is HA, the alternative. Then the third piece is alpha. We'll talk about that a little bit. And my third part is we need to say what curve we are on. So what curve are we on? Okay, so let's go through these 4 parts here under this method step. So like I mentioned before in last class, our null, we can write 3 different ways and our HA 3 different ways. Now the HA comes from the problem. So let me write that here. Actually, I'll write it over here to the side when I'm done writing here, just so I have enough room. So my HA, we can write 3 different ways depending on the wording in the problem. So my HA will be that, now it depends if we're looking at categorical or numerical, if it's P or mu, but that it's a not equal to some value, or it could be less than some value or greater than some value. Okay, that could be my HA. And my null can be exactly opposite, or it could always just be the equals. And I'll make a note of that again. So if it was exactly opposite, if it was a not equals, it would be equals. If it was exactly opposite, if this was less than, then it would be greater than or equal. And if this HA was greater than, then this null would be less than or equals. And I want you to notice that my null always has like the equals in it someplace. So let's make a note that we can always write as equals. Okay, so we can always write it just as the equals if you want. Here, I wanted to make a note that this comes from the problem. So the wording in the problem will tell me what we have here. Now, what you write here is either going to be mu or P. So you would write mu here if you have numerical data. You'd write mu here if you have numerical data. Or you would write P, right? My lowercase p, if you have categorical data. So let me just write an or. So this depends on the type of data. So I will write in here mu if the variable is numerical. So this is why it's important in our population step to recognize if our variable is categorical or numerical right off the bat. So I'm just going to write it twice here just so it's clear. So if I have mu down here in my HA, then of course it's going to be mu in my null because my variable is going to be numerical or categorical. It can't be a combination. And P, if the variable is categorical, I'll write it down here again. Okay, so we need to make sure we pick that out in our first step. Make sure we'll pay attention to that. Now, alpha here, alpha is something that's called the level of significance. Okay. Alpha, we've already talked about in our confidence intervals. This is the area in the tails. On the curve. Okay. And we typically use an alpha equal to 5% or 0.05, which is most of the time. Or we use an alpha equal to 0.01 for medical life or death. Oops, death situation. So our alpha is just indicating the area. Now I put tails and it could be plural or it doesn't have to be plural. And I'll show you in a few minutes the drawings. But that's what my level of significance is. It's how much area is in the tails. And this is going to tell me, and that's why it's my level of significance, if my sample is significant or not. If my sample is going to show support for this new idea. And that's what my alpha does for me. Oops, I didn't mean to write on the 5 there. Okay. Now for my curve, I have 2 ways to go here for my curve. So my curve can either be the T curve, and that is if we're studying numerical data. So remember when we were talking about confidence intervals that we used our T curve for the numerical confidence intervals. Same thing here. We'll use the T curve for our hypothesis testing for means, numerical. And remember this T curve changes shape based on degrees of freedom. So I just want to include that information if we're using the T curve. I'm just going to include degrees of freedom equals n minus 1. You don't actually have to calculate n minus 1. You probably know it already at this point, but you don't need to calculate it. You could just write it n minus 1. This just indicates to me that you understand that this T curve is changing shape, and the shape depends on degrees of freedom, n minus 1. Now, the other curve would be the Z curve. And that doesn't have any degrees of freedom. That one is just always the same set curve. It doesn't change shape. And this is for categorical data. So we can see just in this step alone how important the type of data is, right? All of these things like depend on it. Okay, so that is a really big piece of our first step, is identifying that variable and what kind of variable it is. So if it's numerical or categorical, we could see how everything just relies on that right here. All right, so let's just take a look at some drawings because I want to show you like what these look like. Remember how I always tell you, you should just quickly sketch things out if you can, because it gives you a visual, and I still stand with that. I really think a little drawing is so helpful. So in my method step, we're just going to identify the null, the alternative, alpha, and what curve I'm on. It's actually a very quick, simple step. I think, and it's not even a hard part. It's just my HA, I have to go back and read in my problem above which one it is. And then my null comes from that. And then alpha, 5% or 1%, or it could be given, and then my t-curve or my z-curve. Okay. So it's actually a really quick step. You'll see me work through an example, but that's pretty quick. So let's just take a look at some pictures of what my null and my alternative look like for the different scenarios that we have. Okay. So if we have what we call the two-tailed test, then this is centered. So very similar to our CI, it was centered. So I will have a curve like this. Oops, this kind of comes down more, sorry. We have this curve, and the null is the center of my curve, okay? And my alpha is divided between two ends. So over here, very similar, just like my CI, it's alpha divided by 2 over there and alpha divided by 2 over here. And this is centered. Okay. So this is when my HA is a not equals. When I have a not equals some value. Okay. So that's my two-tailed test. So it's just nice to see what's going on here. And then my HA could be somewhere over here or over here. It doesn't say specifically if it's to the right, if it's greater than, or to the left, it's less than. We're not sure. Okay. And we don't know if it's over here in this area in the tail or if it's closer to the null. We don't know. That's what our sample is going to show us. Okay. So then the next one, we have our left-tailed. So you can imagine what this looks like. We have our normal curve. Again, the center is my null. My area is over here in the left, and that's my level of significance. This is just alpha alone because it's just all to the left. Okay. Oops, forgot my T in the word left. I can't tell you how many times, well, you know, because you watch me write, how many times those things happen because I'm just thinking ahead. I apologize. So here, I'm sorry, I ran out of room. I'm going to write it to the right. I like to keep my notes consistent. But anyways, this is where my HA is less than some value. So we're studying this area in the left. My HA, so that means my sample is somewhere to the left of my null. I'm just not sure where. I don't know if it's over here. I don't know if it's like right here or if it's over here. I don't know. We're going to find that out as we move forward. But these are some nice visuals. So let's just take a look at the right-tailed. As you can imagine, it would be just like the mirror image of my left-tailed. So I have my curve here. You can see how quick these take to sketch out. I really suggest that you guys do this. This is alpha over here. Now my right-tailed, we just say, okay, HA is going to be a greater than some value. That's the scenario. So our sample is going to be over here to the right of my center somewhere. I just don't know where. Again, I don't know if it's over here, like if it's way over here, or if it's halfway, or if it's closer to my null. I don't know. We'll find that out. Okay. So those are the 3 different ways you can set up your hypothesis test. And again, it all depends on the wording of the problem. It's not like a guessing game. It's not like something you're just, you know, trying out. It's like in the wording. So there's something specific. Okay. And there's little drawings to go with it. So let's take a look at the next step. This next step is called the sample step. This is like the quick and easy step. I call this like my break step because it gives you a little break because maybe the first 2 steps were a little stressful when we're starting. And this sample step is very simple. So I'm going to show you for both numerical and categorical because it depends on what type of data I have, what I write in my sample step. So in my sample step, this sample step is going to summarize the sample. So let me just write that over here so we understand what this means. So we don't need to include this in our step. I'm just going to kind of write it over here, I guess, just so you guys know. So this is going to summarize the sample and check that normal, and I'm going to say or T, is appropriate. So what I mean for that is I'm going to use my normality check here. Okay, so let's take a look at the two different types of variable we could have and data we could have and go from there. So if I have numerical data, that means we're studying means. That's my unknown, would be the mu. Then what I'm looking for my sample step is I'm looking for n, which is my sample size. Fill that in here. So this is sample size. Or not or, but and I'm looking for x bar, which is my sample mean. And I'm looking for S, which is my sample standard deviation. Then I'm going to check for normality. So I ask myself, is this normal? Is it symmetric is what I'm looking for. And remember, I have two ways of checking this at this point. So the first way I'm going to use is if n is greater than or equal to 30. If so, then yes, it's true. Or I'm going to use my NPP and see if it's fairly linear. Let's write that linear. Okay. So these are the four pieces I need for my sample step. It's really quick because either we'll be given these first three things, or I might be given raw data and I just need to plug them into like my calculator or Minitab and find X bar and S. Okay. So, and then I would know n because I could just count out how many data values I have. So this could be really quick if I'm given this, what we call the summary statistics. I'm given n, x bar, and s. They would be really quick. Or if I typed in the data into our technology, then we can get x bar and s and figure out n. Okay. So now if we have categorical data, it's still just as quick and easy. Remember, categorical data is when we're studying P, or population proportion. So here we would look for X. Now remember, that's not X bar, that's X. And X here is the number of individuals with the characteristic. So remember, that's what X represents. Then N, again, my sample size. And P hat. So remember, P hat is equal to X divided by N, and we just found X and N, so we can find P hat. And P hat is my sample proportion. Okay. Then again, we need to check for normality. So I want to know, is this normal? Is it symmetric? Right. So the way we do this for categorical data is we use our formula n times p times 1 minus p is greater than or equal to 10. But I have a problem with this formula. And the problem is we're trying to project what's going on with P, what P is, right? And so we don't have P. So how can I use it in a calculation? I can't. I want you to remember what we did with the CIs and what we did in chapter 8 with the sampling distributions. We always used the center of the curve in my normality check. So let's think about what the center of my curve is. So I'm going to introduce a new value. And the center of my curve is called P naught. I'm just going to put a little 0 here. Okay. So P naught, let me just write what this is here. This is called our hypothesized proportion. It's very easy to find this value. It is from my null. It's from H naught. So P naught is just the value from H naught. So if we go back up to our method step that we just did, sorry, my paper is okay. We go back up to my null, whatever number is in here, whatever value is in here, is the value I use here. It's called my hypothesized proportion, P naught. So it's just the value from the null. I'll plug that in there and check. Remember, that is the center of my curve. We always check normality for these categoricals based on the center of our curve. And that's my value for my null. Okay. All right, so what I want to do is I want to take a look at the example from last class and apply these 2 steps. So from last class, I just have to rewrite this. Or maybe I'll just write from last class so I don't have to rewrite the whole thing. And I'll just write some of the information. Okay, so my first example. So same example as last class. And I'll just refresh your memory on what that was. From last class, we were looking at RIT students. And if they approve, of the university's administration. Okay, and that's what we're studying. So I'm going to give you the sample piece. So last class, when I wrote this up, I didn't give you the information about the sample. So let's just take a look at what we did last class. So it just says it's commonly thought that a small percentage of college students approve of the university's admin. An RIT professor wants to convince the campus community that it's more than 67%. Okay, and we went on and we did our population steps. So our objects for all RIT students. The variable is, do they approve of the university admin? It's a yes or no, so it's categorical. It's P we are studying. My unknown, P. P is the population proportion of RIT students who approve of the university's admin. My goal. So my goal is to support that new idea. The new idea is that the professor wants to convince the community that it's more than 67%. This professor wants to show that P, population proportion, is greater than 67%. That's my HA. I'm telling you right now. My goal is always to support my HA. So we wrote our goal. So I want to give some information about the sample, and we'll move on with these next 2 steps, my method step and my sample step. So I'm just going to add this here. So the professor randomly selected 80 RIT students. And asked if they approve of the university's admin. 62 said yes. Remember, for categorical data, we're always interested in those yeses. It's not that we think yes is the correct answer or no is incorrect. It's not that. It's not that we think yes has the majority. It's just that's what we're always studying is the yes. Okay. So you always word your question when you're asking someone in a survey for proportions, like that you're answering for the yes is what you're interested in. Okay. So let's take a look at my method step and my sample. So sometimes it's easier to start your method step before you write your goal, because your goal is always to support your HA. So right here in my method, I need to write my null, my HA, what alpha is equal to, and what curve I'm on. So I usually start it this way. Just like I did with population, I write down the 4 things I need to do, and then I fill them in. And that's typically what I do. So I have my 4 things, and now I could fill them in. So remember, we're studying proportions, categorical data. So my HA is going to be about P. It's about my unknown. So it said that the professor wants to prove that it's more than 67%. So I'm saying P is greater than, I'm going to just write it as a decimal, 0.67. So now, like I've mentioned before, I can write my null with just the equals or opposite. I'm going to write it both ways. So if you want to, whichever way you choose, it doesn't matter. I have it here. So P is equal to point, and it's always the same number here, 67. That number doesn't change. And I'm just going to write it in a different color. And I'm just going to say, or P could be exactly opposite. So if this is greater than, it would be less than or equal to 0.67. You can write it whichever way you want for the null. So for now, I'm going to write it with the equals and here the greater than. So you can see where I got this greater than right from the problem. Now my alpha, I'm not given a level of significance, and a lot of times we'll be given, but if we're just trying to figure it out, then I use 5%, that 0.05 all of the time, unless it's medical or life or death, then I'll choose the 1%, that 0.01. So this is not life or death, so I'm going to choose the 5%. So all I'm doing is just identifying what it is. And I want to identify what curve I'm on. I'm studying P proportions, that's the Z curve. And that's it. So that's why I said this method step's real quick and short. Okay, not a lot to it. Then I'm going to move on to my sample step. So my sample step here, since I'm studying categorical data, I'm looking for my X, N, P hat, and I want to check to see if it's normal. Okay. So X remembers the number of people in the sample that answered yes, that they have that characteristic. So right here, I'm just going to say, okay, the professor randomly selected 80. So 80 right here is equal to N. RIT students, and asked if they approve of the admin. 62, that is my X, answered yes. So here, my X is equal to 62. N is 80. P hat is 62 divided by 80. And I'm just going to write this as a decimal. 0.775. Now for normal, I'm checking N times P times 1 minus. P is greater than or equal to 10. But remember, I use P naught here. It's very easy and to make the mistake of using P hat. Please don't use P hat here. P hat is not the center of my curve. P hat is my sample, okay? So P hat should be far from my center. Remember, the center is my null, so 0.67. So here I have N, which is 80. P naught is 0.67. times 1 minus 0.67. And I want to know if this is greater or equal to 10, and it is because it's like 17 something. So greater than or equal to 10, yes. Normal. Okay, and that's what I show. I need to see this number you're plugging in. I need to see these. The reason why I want to see all of this right here, I don't even need to know what the number comes out to. As long as you tell me it's greater than or equal to 10, that means it's normal, I'm good. I need to see the number because I want to make sure you are not plugging in 0.775, okay? So I need to see that number you're plugging in. So remember, that is from the null. This and this from my null. Okay? It's such a common mistake to use p-hat there. It's right there. You just calculated it. So it's like so simple just to go up and use that, but that's not correct. So I just want to show you guys something that, that I do show my students because I think it's kind of like a nice little way. So when you're working on a population step, this can be tricky. Like this can be a real tricky step for students. Now, this is what we talked about last class. Identifying the objects and the variable, that can be really tricky for some people. So I'm going to show you kind of a way to make it a little bit easier on you. So you see here how in today's example, I gave you the sample piece right here, where it says the professor randomly selected 80, right? And 62 said yes. This little statement gives me all the information about the objects and the variable. So take a look at what this says. The professor randomly selects 80, fine, it's 80, my sample size is 80, but who is it that they're selecting? RIT students. So I could just take that and say, oh, those are my objects, and write all RIT students. And it's like an easy way to find it. Then it's going to tell me what we're studying about those students, right? So if it's numerical, it might say, well, how many minutes it took them to get to school today, or something like that, right? But in this case, it's categorical and it says, asked if they approve of the university's admin. Then I can say, okay, well, that's my variable, right? Do the students approve of the university's admin? Yes or no, it's categorical. So you can use that little piece of information from your sample part to identify the objects and variable up in your population. Because I know students struggle with that. And also, sometimes I say to my students, well, you can skip the goal at first. Don't forget to go back. And you could do objects, variable, unknown in my population step, then go down to method and write my HA. And then say, okay, well, now I can write my goal because my goal is always to support my HA. And so all you're going to say is to find evidence to support that P is greater than 0.67 or P is greater than 67%. That's all that this says. It's just written out in words, and this is written in symbols. But I have the words because I defined it here in my unknown. Okay, so you can see where this all starts tying together. P is the population proportion of RIT students who approve of the university's admin. And I'm just saying it's greater than or more than 67% or 0.67. So my HA is right up here, just in words. Okay, so those are just a couple of things I like to mention to make things a little bit easier on you guys as you are working through the problems. So I do have another example I want to start. And like I mentioned, we'll just continue with these examples throughout these next couple of weeks as we're working through these steps. So it's kind of nice to have examples to build off of, and I'll add some and things like that. So let's take a look at a second example. So it is commonly thought that apples weigh 6 ounces. Okay. A manager thinks the mean, so the average weight of the apples in his store is less than the 6 ounces. He sampled 61 apples and found the mean weight to be 5.6 and the standard deviation to be 0.1. So usually my directions would say complete a hypothesis test to see if you have support for the manager's claim, right? That the apples in the store weigh less, something like that, okay? So the way we're going to start this is we're going to use the whole 5-step process. So I always say it's the complete hypothesis testing process. Just know I always want the complete process. I always want all 5 steps, and we're not going to cut down on this. Maybe when we get in stat 2, we will, but not here in this class. So we're going to start with the population step. So my population step, I want to identify the objects. Remember, this is the who. It is not necessarily people though, okay? So let's go to the sample and see if we can get the information from the sample, because I think it is very easy to find it this way. It says he sampled 61 apples right there. So the apples in his store. So I'm going to say my objects are all apples in his store. Okay. Now my variable. This is what we're studying about these apples. And this is what changes from apple to apple. It says, and he found X bar, so the mean weight of the apples to be 5.6 and standard deviation to be 0.1, sorry. So here it doesn't say mean weight, so I might want to go back up and just make sure. Manager thinks the mean weight of the apples. So that's what we're talking about, the weight. So the variable here, I could just simply say weight, and this is what I liked about the numerical. I could just describe my variable with one word, usually, weight, and then I'm going to indicate that it's numerical. Remember, I like to indicate what type of data is here because everything from here kind of falls into place based on numerical or categorical. Okay, including my very next part here, my unknown. So remember, the unknown is what we're trying to find. And since it's numerical, my unknown is mu. And then I'm going to say mu is the population mean. And then it always starts out the same way. Mu is population mean, but now I want to put it in context. So I'm going to take my variable and my objects and put them together. So it's the population mean weight of apples, or of the apples in his store. Right there, I've defined mu. I've defined what we're trying to figure out or project what's going on with that, okay, which is mu, my population mean weight. Now my goal. So we could just write the goal now, or we can come back to it after we write our HI. I'm going to come back to it. I'm going to just show you both ways because last time we wrote the goal on its own, and this time I'm going to actually come back to it. So here I'm going to take a look at my method step. Remember my method step, and I'm going to write some of them not vertical. I'm going to go horizontal so I could get it all in here. So I have my null and my alternative. So remember, the alternative comes from the wording in the problem. So it's commonly thought that apples weigh 6 ounces. A manager thinks the mean weight of the apples in his store is less. He thinks the weight is less. That's my HA. So he thinks the mean is less than 6 ounces. Okay, right here, 6 ounces. So mu is less than 6. That's my HA. So my null, I'm going to write it mu is equal to 6, or I could write it as mu is greater than or equal 6. That's another way of writing it. I'm not given a level of significance, and this is definitely not medical life or death, so I'm going to choose the 5%. It just means in the area of my tail is 5%. It's a less than, it's a left-tailed. I could picture it right now in my head. It's means, it's numerical data, so I'm studying the t-curve. And with that, I have degrees of freedom, which equals n minus 1. Now let's go back up and write our goal. Remember, our goal is to support my HA. So I'm just going to say, to show support, to say, now instead of writing it in symbols, I'm going to write it out in words, which it's fine. I've already done most of the work up here in my unknown. To say that now it's mu is less than 6. So mu is the population mean weight of apples in his store is less than 6 ounces. There it is. So there's my goal, all based just on my HA. So I think that is kind of an easier way to go. Once you have your method, then go back up and write your goal. You can do it whichever way you want. I'm just going to put a line here because I'm actually going to fill in my sample step real quick over here. So my sample step, not that I'm short on paper, I don't know, I just feel like I want to squeeze it all in here. My sample step, N is how many apples are being sampled, and that's right up here, 61. A lot of times I kind of like highlight or circle or underline this information because it's just easy to do so. N is that. And then X bar and S right here. I'm just going to identify those. So X bar is 5.6. S is 0.1. And then I want to check for normality. So this is an easy one because N is 61. So N is greater than or equal to 30. Normal. Guys, I just want to mention something. I know when you're typing up on the computer, it's not always easy to get X bar or mu. I mean, I can show you how to get them. They're really easy to find when you go to insert symbol, but you could just type MU for mu, or some people just write M, and that's fine with me. But MU, you can write. You can just type out X dash bar. If you wanted to write out X bar, just to give you, a couple of things. I know when we're typing it, it's not as easy just as handwriting.